I will now start my presentation here this afternoon. This is the final one. After that, we will have some summary, if you want to do that. I'm going to talk a little about these massive wood buildings that we are going to see on Friday, which are erected here in Växjö, and that passive house technology within them. Here is the area in Växjö that is called Välle Broar. It's an area between 3 lakes, and this area is for developing wooden buildings with high energy performance. Today it contains some 400 dwellings and 1 preschool. And overall request on this area within the SESAC project was 30 to 40% lower than the national building code. The area will be, or is, provided with 90% of renewable energy from our biomass district heating plant. And there is also a very integrated process from town planning down to construction and maintenance in these houses. This is the overall description of Välle Broar. There are already erected some houses, and one of them is Portvakten North, which has been in operation for 2 or maybe 3 years at the moment. They were the first that were built within SESAC, and the measures that were taken was let's say a little bit normal measures, a little bit of extra isolation, heat recovery on the ventilation system, and individual metering. So far, we know that the result is very, very good, actually. The target, talking about heating and domestic hot water, was 95 kilowatt hours per square meter, and the result from the first year was 75, so it looks very good. And it also looks good at the electrical side. This is the building electricity. It's not the appliance electricity in the dwellings, but the building electricity, which is also lower than the target. This, I think, was the first point where this question of air tightness was raised. In the very end of this project, the construction phase, air tightness was aware in the project, and some measures were taken. Another one, which you also will see on Friday, is Biskopshagen, in another part of the city, where these have been in operation also for 2 years, I think, where the result looked very good, as you can see. It's below target, both on the heating side and the electric side. And in this project, the experiences from building a very airtight houses was really implemented in a hands-on basis. And I think Carina will tell you a little bit more about that on Friday on site. Furthermore, there's another area here called Limnologen that is also part of SESAC. We don't have any results yet, but this is finally erected this spring, and the monitoring process has just started, so we don't have any experiences yet. But this is the first house with wood structure, 100% wood structure, in 8 stories. The energy performance is let's say 10-15% lower than the building code of today. Then we come to this passive house that has been erected and will be finished. The last one will be finished in October now, and we will see them in reality on Friday. It's 8 stories with passive house technology with a wooden structure in it. This is the company in Växjö, Hyresbostäder Växjö, that has been building it, owning this. The Energy Agency of Sweden has been involved, and this is a research institute that's also been involved, and all of us in the SESAC has been involved in different ways. It is a little more description of this is that there are 64 apartments in 2 buildings, 8 stories, I have said, massive wood design, and typically for a passive house is that there is no ordinary heating system. This is possible because if we build it in a very airtight way and we do a lot of insulation on the walls and in the windows, it is not necessary to have an ordinary heating system because you take care of all the waste energy from the appliances, from lighting, from your television, from your cooking, etc., etc. And on top of that, this is to produce this using wood means that you produce a low level of carbon dioxide, and on top of that, the structure itself is a carbon sink that will store carbon dioxide until it's demolished, the house. Here is a little bit more technical presentation, and I'll go into that very briefly here. As have been said very many times today, air tightness is a crucial thing, talking about passive houses, and so is, of course, the amount of isolation. You need both of them to make it work. But we also need we have a mechanical ventilation inside this house, and that is conventional technology in Sweden, actually. Many new houses have mechanical ventilation, double flux ventilation. But in order to meet the passive house requirements, you need to have a high heat recovery factor. And in this house, it's 85% over the year. So 85% of the heat going out from the house in the ventilation is recovered to the supply air side. That is actually one of the really progress made here from our producer, the EV product, that also really made this invention for this house. That was the first time. And that was the result from putting request on the market. So, because when we started this project, we couldn't find this on the market, this kind of equipment. You couldn't find that on the market, so we needed to invent it in some way. Besides that, there is also a heat recovery on the wastewater. The wastewater system going out from the house is passing a heat exchanger where the heat is recovered into that water that will become hot water into the house. And then is a connection to the district heating system producing domestic hot water. There's also individual metering in each and every apartment. There's an individual metering, so people can see what they use, what it costs, and so on. And of course, I said district heating, it's bioenergy. And there were also plans for a PV system on top of the house here to demonstrate this technology and to use it inside the house. That was the meaning, but so far we have not succeeded to put it there. And that's because of economical reasons, of course. Still, I hope there is a chance to do that in the future. But that's it. There's no ordinary heating system. It's a sewage system, it's a ventilation system. there is one redundant system, and that is if you leave, or I should say, put it like this: if these apartments are used in a normal way, and that is you sleep in your apartment, you wake up, you make your breakfast, you put on your light, you use your radio, etc., and then you go to work, come back home, you start your wash machine, etc., etc. If you do this in a normal pattern, it works by itself. It doesn't matter if it's minus 20 degrees outside, it works by itself because of this. The challenge is when you're not doing this pattern. When you go for vacation in wintertime, for instance, then of course also a passive house cools down if no waste heat is provided. And this is this little bit here up here. It's a redundant system. It's a 1 kilowatt exchanger connected to the district heating grid, so it's biomass energy that is automatically provided to the apartment if it's necessary. Yes. The main item here, I would say, is the construction, the wood construction, and this is the base of that. It's a 83 millimeter solid wood, making the core of the wall. Outside this core, there's a lot of insulation, and there's a sheet outside here to prevent rain from coming in. And there's also a little insulation inside of it. And you should see these pictures here, but I can understand you cannot see it. You will see it when you come to the site on Friday, because we have a model of this there. It's 53 centimeters wide. Most of it is, of course, isolation. Another very specific and very crucial thing about this passive house is that you need to do the construction work under a tent, because these prefabricated items made out of wood cannot get wet, because then it's a big problem in the future. They need to stay dry. They arrive at the building site at approximately 13% of humidity, and we need to have them at that level through the building process. So that's why a tent is necessary, and this tent is a very specific construction that, of course, is down here when you started to erect the first floor, and then it raises up all the way. And that is the construction company, NCC, that invented this construction here. Yes, you see NCC here. Furthermore, you can see, well, maybe you cannot see it, but there's as I said, all the components, the wall components and the floor components, they were prefabricated in factories, in 2 factories. They were tested of their air tightness in that industry, pre-tested. They were delivered to the site on a truck, and then they were lifted up here on the side, beside in a yeah, what do you call that? A crane, yeah. The crane lifted up all this stuff up here under the tent, and it looked like this. Here you see the crane. Here is a part of the wall, and in the wall there were already the windows and the doors, and the exterior material was also there. It was not painted inside, but otherwise everything was there. These things were assembled at site. Here you see a little bit more. Maybe you can see the depth of the wall here, 53 centimeters. And this is taken only 2 months ago, when it was in place, and you will see it on Friday as well. And it gives you a special feeling to see that on site. Here you can see also the floors floors being mounted on top of the construction like that. And as you can see, it's a specific designed floor in order to take care of all fire protection questions, all noise questions, etc., etc. And there's also a specific solution with the piping, both the piping for water and wastewater, but also ventilation. They are placed here inside this floor, already on the factory. So it was only assembled at site. All these things made it very quick to assemble at site. So I think it took some 8 or 10 months to do this on site, and that is very quick. In one shift during the mounting area process, it was only 8 people working, putting all these things in place. This was very much technology and installation and so on, but on top of that, there's also a demand-side management thinking in this project, and that is, as I said, the individual metering and the system that is built in to give the inhabitants information about their use of energy. They can see it themselves on a display in the department, but they can also visit the web and to find out how they behave in comparison with their neighbors, more or less. And that is a good start. There's a program going on called SAMS, which is a citywide program trying to reduce electricity all over the city here. I think was it 5% or was it 5%? Yeah, 5% goal to do that. And I think we have not yet reached that goal, but hopefully we will. So just to put this technology and this house in a perspective, I will show you this picture. This is a picture showing that from 35 years ago, in the early 70s, the average use of energy in a multi-family house in Sweden was approximately 350 kilowatt hours per square meter for heating and domestic hot water. Then there was an oil crisis, and there were building codes getting more restricted on this matter, and the curve you see here in existing buildings was decreasing all the time. So in the beginning of 6 years ago, the average was approximately 170 kilowatt hours in the total existing amount of multi-family houses in Sweden. And to put in this passive house, we can see, yeah, you cannot read this. Oops. Yeah. You can see this very, very shortly, but this was 170, and with this passive house, we have calculated so far, but we have calculated a lot, I can assure you, that we will reach approximately 1/3 of this. This is the new building code, so we will end up 1/3 below that in heat, in use of heat, which is very good. And if you compare this figure here to that, it's approximately 1/10, but it took us 35 years to do that. So I think this picture shows these kind of questions takes time, and that's why it's so important with political decisions and a strong commitment of everybody. I will end up with 2 slides here showing a little bit more overall things. The lessons learned in a very summarized way in SESAC so far are these. And I think that goes for many of the projects we have heard of today. In order to reach the goals, it is necessary to integrate these RES thinking, the renewables, and the rational use of energy thinking from the very first beginning of the project. That is necessary. Otherwise, it won't work. It's also very important to continuously to verify during the period, follow up all these requirements, and to be sure that we are on the right way. And finally, everybody involved in this need training. Everybody. Also, people that are designing, people that take decisions, people that are assembling things at building site, etc. Everybody needs training in some way. Then, how is it to live in a passive house? We have asked people that have lived in other passive houses. They say it's quiet. It's very quiet. That's good. It's good ventilation. It's very good indoor climate, as you say. We have also these restrictions, as you told us. It's a very stable indoor temperature. It's the same. There are no cold zones close to the windows. It's no problem. You can sit very close to the window, but you cannot have there's not a radiator. It's warm. It's of course low cost for energy. You need to do more airing actually, because it's easy to get a high temperature in this kind of houses than in a normal house, if we say so. You need to open your window a bit more. Especially if you have had some friends for dinner at home, you need to open it a little bit more. And finally, it's good for your green conscience. It's a pity you cannot read that, but so it is. I would end my presentation to give you just the key success points that I see in this process. And it's these four here. First, it's the management competence, and we have been speaking about that a lot of times today. And that is to run such a project in a proper way, setting the requests, follow up, and to do continuously verifying of all these things. It is, of course, the competence in performance to make people and organizations possible to produce these things. A splendid example is in Grenoble, where they had this training of workers. We have had that in Sweden as well, and also in Holland. But there was special training for workers in doing that. Cooperation is a very good word. This is a new way, in many ways, it's a new way to cooperate, and it needs conversation and dialogue and information, a lot of that. And finally, a technical word here, and that is the air tightness. And this figure here shows how the air tightness was verified in these passive houses. It was it's the blower door test, meaning that in the front door you put in a ventilator here, a fan, and you close the door like that with a plastic layer, and then you monitor how much air is coming out of that hole, and then you can count on the air tightness. And this was a really request in this project, of course, and it was very well verified afterwards. Okay, thank you very much. It's time to close the down. Are there any questions? Yes. Can you help me, Niklas? Yes, please.
I have two questions. The first question is, in Holland we use also heat recovery by ventilation, but it is being discussed now very much because people get headache or they got breathing problems, etc. Do you recognize that those problems?
No, actually not. As I said before, this technology mechanical ventilation in dwellings is quite normal in Sweden since 25 years ago, with a heat exchanger in it. And when the first passive houses came to Sweden approximately 5 years ago, this was investigated very, very carefully and by researchers. And the result coming out of that, because the ventilation equipment is very, very appropriate. It's very good. They couldn't find any troubles with that in these new passive houses. People were very satisfied with the indoor climate, actually. It was a stable temperature, it was quiet, and so on. So that has not come any problems so far.
We must be doing something wrong in Holland, I guess.
I don't know.
My second question is, when is a passive house called a passive house in Sweden? In Germany, they use the BHPP method. Yeah. Is that also in Sweden?
No. There are different definitions. We don't use the German version. We use a Swedish version of passive house. It is, if I translate that very roughly, I can say that it's a house without a normal heating system. Yeah.
Thank you.
Yeah, into the same kind of questions. You need a very airtight shell.
Yeah.
And how are these houses in 50 years? Maybe there have been some drilling, there's been some painting. Are they still healthy and energy efficient?
I will show you this picture again. In 50 years, yeah, it's not easy to answer that exactly, but of course, the main measure to make it airtight is to put a plastic layer here. Here's a plastic layer outside the solid wood structure. It's outside. This is inside of the house. So if you do your put nails into it and so on, you will not reach this layer. It's more or less impossible. So that is not a big problem. A crucial thing is that if this wood here is too wet, to have a too high humidity when it's mounted on site, that could be problems. Calculations and cooperation with Lund University shows this, and that's why there was a quality control of all the delivered parts to the site in order to secure that it wasn't too much humidity. That can be a future problem, but so far it's nothing. That is what we are, I can say that is what we are aware of at the moment. We have, in Sweden, we have passive houses that are, the oldest one is 8 or 9 years at the moment. So we don't have a long history of it in Sweden. They have longer history in Germany for, let's say, 20 years or so. And there have so far not been reported any big problems. Okay?
Did you take into account that the appliances would become more energy efficient in 10 years' time? Like a washing machine will not use a lot of energy or produce a lot of heat?
Yeah, that's a good question. We rely on the appliances in some way. Yeah. But the fact is that we have a surplus already today in that question. And what is happening is that you need to do a little less airing. If you reduce your dishwasher machine by 25%, it's no big deal. Not in the coming 20 years, I think. It's no problem. But of course, if this continues to be lower and lower and lower, there's a limit somewhere. It is. Yes, you're correct. That is really not a big problem. Either you fix a potty, or you make some baking in your oven. That will fix it.
What about the cost of the building?
Yes.
Is it for sale or for rent or for tenants?
This is for rent.
For tenants.
Yeah, yeah.
So you sold it to
The production cost of these houses is approximately 10% more than a normal house. The investment cost. And that is the reason, of course, is that this is the first multi-story house made out of wood that was constructed. I think, and many actors on the building sector think that it will not be an extra cost in the near future to produce these houses. This is a learning process going on. And when we have reached a certain level, it will not be more expensive.
So even if it is 10% more expensive, the operating cost.
Yeah, sure. Yeah, sure. It's good. If you look at the life cycle cost already now, it's a good business. Yeah. The question was if this 10% was because of the wood construction or the passive technology construction, and that is probably a combination of both. Talking about cost is very difficult. What I say now is 10%. That is the experiences of this local housing company. If we go and ask our friends in Stockholm or in Malmö, they think this is cheap. Yeah. Even if we go to a smaller community in our neighbor region here, they think this is cheap. So it's a little difficult to make a wide yes about this. Yeah.
Did you have to change, have any changes made to any building codes? I'm just thinking, I don't know if you could build this.
We didn't change the building codes, no, not yet, not in Sweden, but I can assure you that what has been achieved in Grenoble has affected their building code. There is a process going on now in Sweden where this definition that is actual at the moment will be replaced by a new one or not. That's a discussion going on. And that is a very good discussion actually, because that takes into account much more than the building code says. So probably in the near future it may affect the building code as well. I think so. Okay. Please repeat that. I couldn't hear.
Is there also some developments in the insulation material which is being using? You are using now glass insulation, glass wall. Is there some developments in that part?
Yeah. In this project, it was not. This is conventional material all over. It's glass fiber, yes, a stone wool. But I think my personal thinking here is that these walls are 53 centimeters wide at the moment. And somehow I think this is more or less what we can accept, not more than that. And that means that if we go further, we need to find other materials in order to increase the insulation capacity. And I know already that there are new materials in our neighbor countries coming up, which can be very interesting to use, actually. I think so. The wooden structure, I should say, because that has not been mentioned before. From the very early beginning, there were no thinking of doing it in a wooden structure. But after 1 year's work or so, the owner of this housing company, the owner, political owner of this housing association, decided that this should be a house with wood structure, because that was a very tough and good decision. They saw possibilities in this that would further develop technology. It would further develop the wood technology, because our university here is very good at that. And this means that it connects the energy issues together with the wood issues in a very good manner. A wooden structure house has many good things. One of them is that it doesn't weigh so much as concrete, which can be very interesting in Holland, for instance, where you have lots of water in your ground, etc., etc. So this was a political will, we can say, to build it in a wooden structure in order to increase development in this sector. Thank you for that.